Okay, here's warm-up 12.3. All right, we're when two number cubes are rolled, so those are just dice, right? When two dice are rolled, six-sided dice, find the probability of rolling doubles twice in a row. All right, so to probability, we're looking for the number of favorable outcomes over the number of total outcomes. All right, so here we're going to be finding probability of rolling doubles, and then the probability of rolling doubles again. So we're going to multiply the probability of those things happening together. All right, so D is for doubles, our probability of doubles. So let's just figure out what how many favorable outcomes. Well, the number of different ways you can roll doubles are 6, because you could roll double ones, double twos, threes, fours, fives, or sixes, right? And then the total amount of things that can happen when you roll two dice, well, there's 6 things that can happen on each dice. 1, 2, 3, 4, 5, or 6. And so you multiply those together. So we've got 6 out of 36 probability of rolling doubles once, which would reduce to 1/6. So then I can say, okay, for the first time you roll the number cubes, you got a 1/6 probability of rolling doubles, and you got that same probability on the second roll. And then when you multiply those together, it's 1/36th probability, or you could do the percentage version of that. Okay. All right, next problem. Find the probability of drawing a jack and then drawing a king from a standard deck of 52 cards without replacement. So we've got one event happening followed by a second event. Okay, so we're going to find the probability of drawing a jack. Okay, and then we're going to find the probability of drawing a king, assuming that a jack has already been removed from the deck and not been replaced. So that's why the phrase without replacement is important, because we're going to remove a card from the deck after the first event. Okay, so our first event, the jacks, well, there's 4 jacks right here out of a total of 52 cards. So you got a 4 out of 52 probability of drawing a jack. Okay. On the second draw, we're going to be find the probability of drawing one of these kings, but you got to assume one of the jacks has already been removed, because let's say on the first draw, we pulled out the jack of clubs there. Well, that's gone then. Well, there are 4 kings in the deck, but there would only be 51 total cards left. Okay? And then when you multiply straight across, we get 16 over 2,652, that's what 52 times 51 is. And you can reduce that. 4 goes into both of those numbers, so if you divide by 4 on top and bottom, we're going to get 4 out of 663. Pretty small chance of rolling doubles twice in a row. Okay. Next up, Gandalf has 4 pairs of boots, 28 robes, and 10 hats. How many unique outfits does he have? So our outfit's let's assume it's 1 pair of boots, 1 robe, and 1 hat. So I'm going to use the fundamental counting principle here. You could make an outcome chart, but it will get really big. And so this is going to be a lot easier if you use the fundamental counting principle. So I'm thinking about my 3 different categories here. And okay, we've got 4 boots, 28 robes to choose from, and 10 hats. So if you choose one from each, fundamental accounting principle says you can multiply the number of options in each category together, and that will give you your total amount of possible outcomes. And then so we've got 1,120 possible outfits there. Okay. All right, this last one, we are drawing marbles out of a bag. Okay, so I'm going to draw a little picture of my bag here. Here's my bag. And then we've got 5 blue marbles. I'll just put B for blue marbles. Okay, there's 5 of those, and 4 reds. Okay, so there's my bag of marbles. All right, so we're going to find the probability that we randomly select a blue marble. And then we're going to select another blue marble without replacement again. So my second blue marble, I'm going to assume that a blue marble has already been removed out of the bag. Okay. So first blue marble, well, there's 4 blue marbles out of a total, there's 5 blue marbles out of a total of 9 marbles, right? So 5 out of the 9 marbles are blue. Okay. But on the second draw, I've already pulled that one out of the bag, and now there's only 4 blue marbles left, and there's only 8 total marbles left. Okay? And then multiply straight across. I'm going to get 20 over 72. And that's going to reduce as well. You can divide the top and bottom by 4, and that will put you at 5/18. Okay, that's the end of the warm-up, and I'll see you next time.